Hi, I'm Joshua Wilson, and today I'm going to show you how to build your very own salinity sensor so that you can go out and take measurements of the amount of salt in lakes, streams, ponds, rivers, your swimming pool, whatever you want to do. You may want to find out if you've given your goldfish way too much salt and it's now going to die. So you can find out how much salt is actually in the water, and then you probably want to look up online how much goldfish can handle. I don't think it's that much. Anyway, let's get cooking. Okay, well, to start off, we're going to need to know the materials that we're going to need to build our salinity sensor. So I've got a nice little list right here. The first thing you're going to need are 2 nails. Now I used 3 32 inch nails, but a different size would work as well. The next thing we're going to need is some wire. Pretty much any gauge of wire should do. Whatever you have lying around the house, or you can go to any electronics store and get wire. The next thing we're going to need is a resistor. Now, this is pretty flexible. You can use a lot of different values, but I found that a 1 kilo ohm resistor seemed to work pretty well. We're also going to need a thermistor if you are also planning on measuring the temperature using the sensor. And next, the final thing we're going to need is a watertight container to store the sensor so that we don't get water in it. Now I have on the board a list of the tools that you're going to need to build your salinity sensor. The first item on the list is a thermocouple. You may or may not actually need the thermocouple depending on whether or not you've decided to do your own temperature calibrations for the sensor and for the thermistor you're using. The next item is a multimeter. You will almost certainly need this, as it's very important for measuring the actual resistance of the resistor you're using, as well as testing various elements of the circuit. The next item is a hot glue gun. Again, you may or may not need this item. I used the hot glue gun to seal the holes I drilled in the watertight container that we'll be using later to contain the sensor. But you may decide to use some other means of sealing the container. The next item is a soldering iron. The next item is a drill, which you will need for drilling holes in the watertight container. Now that we have all of our materials and tools, we're ready to build our salinity sensor. The first thing that you're going to want to do is take your watertight container and drill a couple of holes in it. I drilled holes that were big enough, just big enough for the 3 32 inch nails to fit through at a distance of 10 millimeters apart. Now, you don't need to be really precise about this. I took measurements and figured out that the distance that the nails are apart is actually not a really big deal. So try and get them about 10 millimeters, but don't worry about it too much. The next thing you're going to need to do is to calibrate your thermistor. If you bought your thermistor online or from a store, it may have already been calibrated, and so you might already know what the K value is. But it never hurts to check. So what you're going to want to do is get some cold water, and you'll put your thermistor in the water. And I'd let it sit for a little bit, adjust, and get to the temperature that it's supposed to be. And then use a thermistor or a thermometer or something else to measure temperature to check the actual temperature of the water. Then, once your thermistor has reached equilibrium temperature with the water, go ahead and use your multimeter to measure the resistance of the thermistor. Then, heat the water up to a higher temperature and repeat this process. Now we're going to learn how to build the salinity sensor circuit. Basically, we're just going to put the nail gap in series with the thermistor and the reference resistor between the power source on the data logger and ground, and then measure the voltage output before the thermistor and the reference resistor. So there you have it. That will be our circuit. So we have, I'll reiterate again here, we now have the data logger, voltage out on the data logger going to the salinity sensor from the salinity sensor to the thermistor, from the thermistor to the reference resistor, and from the reference resistor to ground on the data logger. Now we need to hook up our connections to the data logger. So first, we want to measure between the reference resistor and ground. So we'll put another alligator clip before the resistor and connect it to pin 1 on our data logger. And finally, we'll measure our second resistance, which will be from before the thermistor, and we will measure before the thermistor to pin 2 on the data logger. And this will allow us to measure the voltage drops across the thermistor, the resistor, and the salinity sensor, thereby determining the resistance of the thermistor and the salinity sensor. After you have your circuit completed, you can encase put the entire thing inside your watertight container. Be careful so that none of the wires touch, as that will mess up the values you get. This is what mine looks like. Looks kind of messy, but it'll get the job done. Okay, well now that we have our salinity sensor all put together, we can take it for a test run. So first, I'm going to go ahead and turn the data logger on. You'll see the lights come on. Close it back up. Seal it. Put it in the water. And hopefully it won't flip over. But anyway, so right now it'll be collecting salinity data and voltage measurements for our sensor. So that should be long enough to have gotten some good data. We'll go ahead and stop it and take our data over for analysis. Okay, well we plugged in the data logger and we've loaded the data here into MATLAB and brought up the code that you can find online to help you analyze your data. So here we're going to go ahead and run the code. Runs pretty quickly, and we see that here we come up with a chart of resistances. We got a few outliers here, but for the most part we have a fairly consistent and a good average for the resistance, which will allow us to calculate the salinity of the water. Alright, well thank you for watching. Now we have successfully built and tested our salinity sensor. I highly encourage you to build one of these and go out and learn some science and have some fun. Thanks.